Hi, today we're learning more about solving quadratic equations. So you did this in grade 10, but it comes up a lot again throughout grade 11 and grade 12. So we're going to do another note on it just to really solidify and make sure you understand how to do it. So this is a quadratic expression. What makes it an equation is when we set it equal to something. So this quadratic expression, x squared plus 6x plus 8, can be modeled by a parabola, which I drew for you here. This would have a vertex of -3, -1. Okay, so as soon as we set it equal to something, so let's say we set it equal to 0, that means we want to find the x values on the left side that satisfy the right side. So that would make this side of the equation equal to 0. So what x values, when I put them in, would give me 0. So for instance, if I put 0 in here, would I get 0? Well, no, because I'd get 0 plus 0 plus 8. So that wouldn't work. If I put -1 in, would that work? I'd get 1 minus 6, which is -5 plus 8. That's not 0 either. So you could do a trial and error, but obviously, who wants to spend their time doing that? There's a faster way to do it. So graphically, this means the point of intersection between this side and this side. So visually here's our parabola. Asking when this equals 0 means finding these spots when the y value is 0. Okay? If I let this be equal to 3, then that would mean I have to, and if this is the y value of 3 here, okay, I would have to find that the x values that would give me those points, okay? So when the parabola is hitting 3. If I put, so in that case there'd be two different answers. If I put -5, I'd be looking down here, and notice in that case I wouldn't get any answers. Okay, if I set this equal to -1, that would be right at the vertex, so I would only get one answer. Okay, so that's what solving a quadratic equation means. It means finding the values of x that will make the equation true, that will make left side equal right side. And visually, it's a point of intersection between whatever parabola this gives us and whatever horizontal line is given to us on the right side, okay, created by that value. So, you can get out your notes. Okay, make sure you fill this all in. Okay, this is important for you to understand for a communication question, or just, I could ask you a thinking question that would use this kind of knowledge. It's important that you understand why you're doing what you're doing and not just going through the motions. You know, that's the difference between maybe a 7D student and a 9D student. Okay, so solving an equation means finding all the values of the independent variable that satisfy the equation. So in other words, finding all x that make the left side equal right side. Graphically, this means finding the x values of the point or points of intersection between the curve on the left side of the equal sign and the curve on the right side of the equal sign, which could be a horizontal line like my example showed. Okay? So to solve a quadratic equation algebraically, you need to move everything over to one side so that you have a new quadratic in this form, okay? ax squared plus bx plus c equals 0. You have to have the equal 0. Then you're finding the zeros of this new rearranged quadratic formula, or sorry, quadratic equation, I should say. And you do that either by factoring or by using our good friend, the quadratic formula, which you should have memorized. And remember, it's easier to do either of these things if you remove any possible common factors that there are. It just makes your life easier, even with a quadratic formula, because you're not using such big numbers. But if you don't do that, you're still able to do either of these things, okay? So our first example is as simple as you can get. It's just solve this. Okay, so x squared plus 6x minus 2 equals 10. So, first step is to rearrange, so you need to move this 10 over here. So you have x squared plus 6x, and then minus 2 minus 10 is minus 12, equals 0. Make sure you include that equals 0. Okay? So now you have to think, is this factorable, or do I have to use quadratic formula? Well, in this case, you do have to use quadratic formula, okay? So remember, this is your a value is 1. There's a coefficient of 1 there. Your b is 6, and your c is -12. So x equals minus 6 plus or minus the square root of 6 squared minus 4 times 1 times -12 all over 2 times 1. Now, often students try to do this in their calculator all at once, and I don't actually recommend that because there's a lot of human error that comes into play when you do that. So I suggest first finding what's underneath the square root. Okay? So minus 6 plus or minus, you do 6 squared minus all that, that gives you a positive 84 all over 2. Okay? And then you can simplify that denominator as well. So this is easier then to actually go through and do. So this gives you minus 6 plus or minus. Now, root 84 can instead be written as 4 times 21 all over 2. Okay? So the root of 4, is 2. So you can actually pull that out. So it's just 2 times root 21 all over 2. Okay? To simplify this even further, I can pull out a common factor of 2. Okay? So I'm left with minus 3 plus or minus root 21 all over 2. And then these cancel out. So my final answer is minus 3 plus or minus root 21. And yes, I want you to leave it in this form. Okay, this is a general problem, so you should have the solution as exact as possible. In a word problem like the next one, decimal answers are more appropriate because you're talking about money or time or height. You want a decimal number. But in a general solution like this, you should keep it as exact as you possibly can. So minus 3 plus or minus root 21 is the best answer here. Okay, so make sure you really understand that example. Go through it again if you need to. Use the steps above to help you if you need it as much as possible, but that is the most basic problem that you're going to get in your homework. It's definitely going to be on the test. That's the easiest type of problem you'll ever get. So make sure you understand that completely before you move on. Okay, example 2. Here's a typical profit function, and they want to know X is the quantity sold in thousands. They want to know when the company breaks even. So break even, remember, just means P at X equals 0. Okay, it means no profit. You just make nothing, but you don't lose anything either. So that's the equivalent of solving negative 0.5x squared plus 8x minus 24 equals 0. So what x values, what quantity would make the profit 0? Okay, so you can use quadratic formula here if you want to go ahead. I'm going to factor just to show you another way of doing it. So you can common factor on a negative 0.5. So you're left with x squared minus 16x plus 48 in brackets equals 0. Now you can divide this on both sides, so the minus 0.5 actually goes away because 0 divided by minus 0.5 is still 0. So you're just left with x squared minus 16x plus 48 equals 0. And you can think about what multiplies to 48 and adds to negative 16 was x minus 12, x minus 4. Okay, so that means either x minus 12 equals 0, so x equals 12, or x minus 4 equals 0, so x equals 4. So there you have it. And remember, these are in thousands. So your sentence would say, therefore, selling a quantity of 4,000 or 12,000 units results in break even for the company. Okay, you can try quadratic formula. You should get 12 and 4 that way as well. Example 3 is a very, very typical question that you're going to get in quadratics. It's very important to understand these fall questions and when they're at a certain height, okay? So when you're given a negative a value, this is rounded to minus 5. Often it's minus 4.9. You might know that that's acceleration due to gravity. Okay, so that means that it's a downward facing parabola, and that this c value here is always the intersect of the vertical axis. So in this case, height. So that's the height the ball is at when t is 0. So at 0 seconds, so this is t, and this is h. So at 0 seconds, the ball is at 10 meters high, okay? And then we are assuming it goes up and then goes back down again. I just drew up the most basic thing ever just so you could visualize what's going on here. So they want you to find the domain and range. So normally the domain for a parabola would be any real number, but this is within a realistic situation. So the domain, remember, has to do with time. So we know that it has to be greater than 0, but we also know that it has to stop when the ball hits the ground, okay? Time doesn't go on forever in the height of this ball situation. So we know this is 0, and then we need to find what that is in order to find the domain. So that is the 0. So we need to set minus 5t squared plus 30t plus 10 equal to 0 in order to find the domain. So let's factor out a minus 5. Sorry, I forgot to write the plus 10 here. Okay, and you'll notice that that's not factorable, okay? There's nothing that multiplies to -2 that adds to -6. So we're just going to use t squared minus 6t minus 2 equals 0 in the quadratic formula. Okay, so you can go ahead and do that, and you'll get t equals 6.32 seconds. Okay, that's the only one that's admissible. You'll also get a negative answer, but that's not admissible here. So now you know that your domain is t, make sure you use the right variable, such that t, the time has to be greater than 0, but it can be equal to 0. And then less than or equal to, because it goes until right up until the second, 6.32, and then it can be any real number because time can be a real number, not just an integer. Okay? Now it wants us to know the range. So think about it. The range is the height. What is going on with the height here? How low, how high? So lowest height is 0, and the highest height is going to be whatever that y value of the vertex is. So for the range, you have to find the y value of the vertex. So this is in standard form. Remember, the easiest way to find the vertex from standard form is to do minus b over 2a. So the vertex, the x value is minus b, so minus 30, over 2 times minus 5. So that gives us 3. And then we just find h at 3 in order to find what the height is at 3 seconds. And that's 55 meters. I'm approximating just a little bit, okay? And so there you go, that's the highest height. So therefore the range is height such that height is greater than or equal to 0 and less than or equal to 55, and height is also in the set of all real numbers. So there you go. So that should answer your question about domain and range. So I hope you see how this little tiny, simple, not very well sketched visual can still really help you when you're figuring that out. So now it's asking, when is the height of a ball above 30 meters? Well, we know that this is 55, so again, this isn't well sketched at all, since this is supposed to be 10 and this is supposed to be 55. But obviously 30 is somewhere in between. So there's 2 points, one on the way up and one on the way down, when the height reaches 30. So between those 2 points, it's above 30 meters. So basically, we want to know when the height equals 30 meters, and then we can go between those 2 times to answer this question that's being asked. So we put minus 5t squared plus 30t plus 10 equals 30, and now this is the equation that we're trying to solve. Okay, so how about, let's make sure this is a negative. So how about you pause the video right now and try to solve this equation on your own, then come back and check and make sure you did it properly. Okay, so you get minus 5t squared plus 30t minus 20 equals 0. Okay, you can factor out a negative 5 just to make your life easier. If you didn't do that on your own and got the right answer, that's okay. It's just something that if this were factorable, it'd be a lot easier to see once you take out that minus 5. And even for using quadratic formula, it's a lot simpler. So once you do quadratic formula, you should get t equals 5.2 and t equals 0.76. These are both seconds. So now you need a nice therefore statement. Therefore, the ball is above 30 meters between 0.7 seconds and 5.2 seconds. Example 4. This is a more difficult example, okay? I'd like you to try it on your own as much as possible, given this very simple diagram I drew. This is the area of the factory in the middle, okay? And think about it, the lot is 80 times 60, and then there's a lawn surrounding the factory of uniform width, okay? So the factory itself here is 80, and this is 60. And this width, even though I didn't draw it well, is all the way the same around. So this is W here, and this is W here, and this is W, and this is W. So this green area around here is the same as the area inside here, which you should be able to find. So what you need to do is come up with an expression for the area of the grass and set it equal to what you know to be the area of the factory, and then solve that equation. So this is a higher level thinking, problem-solving question. I'd like you to try it on your own, and I might do the solution in a separate video, or we might do it together in class. We'll see. Okay, so good luck. Thanks for watching today, and I hope you learned lots.